Okay, so we're going to continue on with our chapter on proportional relationships. And today and tomorrow, the topic is called the same thing, solving proportional relationships. Now, today and tomorrow, we are starting with the fact that all these relationships are already proportional. So we've talked past 2 days about how to figure out if it's proportional. We assume that everything is proportional with the questions that we're solving today. Now, what were the 2 reasons why something would be proportional? What are the 2 reasons we can give? What's one of them? Okay, constant ratio or the same unit rate. The constant ratio is what allows us to do this. So everything that we're doing today goes back to the fact that the ratios are the same. And so that's going to kind of be the premise of how we can solve these problems that we're going to look at today. So a proportion happens in a proportional relationship. What a proportion is, it's an equation that states that 2 ratios are the same. They are equivalent. So think back to what we talked about the past 2 days and what we just said. Constant ratios or equivalent ratios, that's what a proportion is. It just says that this ratio equals that one. And then one thing that's going to help us solve these problems today is called the cross product. So get that down and then we'll talk about how to find it and kind of what it does. Okay, so in this definition of cross products, A, B, C, and D, they could be any number. So you could plug in any number as long as it works, like 1 over 2 equals 2 over 4. So the way that we find the cross product is we would do A times D and B times C. So we are multiplying, product means multiplying across the equal sign. So we'll do A times D and B times C. And notice that last sentence there, the cross products of any proportion are equal. So that's one thing. This is going to allow us to solve all of our problems today. So the cross product, you just multiply across the equal sign, and then the cross products of any proportion are going to be equal. And that allows us to do what we're going to do today to solve these proportions. So our proportions that we're going to be looking at today, they are going to look like this. 3 numbers, or 3 of these are going to be numbers, and then there's going to be 1 missing piece, and we're going to find that missing value to make sure the proportion would would be satisfied. So when creating proportions, because sometimes they're going to give it to us, sometimes we've got to make our own. So when creating these, there's going to be 3 known values and 1 unknown value. So out of those 4 numbers, we'll know 3 of them. So what we're going to do is put a variable in the place of that unknown value. And this stuff, when we start to create our own proportions, we'll go back to these, but the same units must be in the same place. So if we had miles and hours, if miles is on top for the first ratio, miles has to be on top for the second. Hours has to be on the bottom. So that's what I meant by the same units must be in the same place. A variable in math, what do we usually use as a variable? We use, X or any letter. Yep, so we could be a letter. And a lot of times we are going to use X, but you could use, like if we're trying to find, I don't know, how many miles, you could use M for miles. So you could all use a letter that satisfies what you're trying to find. But what the proportions will look like will be something like this. 1 over 2 equals X over 4. And so our goal is to figure out what does X need to be to allow this fraction to equal that one. So that's what we're going to be doing today. Sometimes it'll be easy to see like this one. I think it's easy to see X needs to be 2. 1 over 2 equals 2 over 4. But sometimes we're going to have to use the cross product to figure this out. So a couple other things. Once the proportions are set up, if we have to create our own, once we've got them set up, then we find the cross products. And we're going to multiply those together and write those 2 numbers equal to each other. Because like we just wrote down, the cross products of any proportion are equal to each other. And then we're going to be solving a one-step equation. I know we haven't talked about that yet this year. It's something we'll look at a little bit later. But we're basically going to divide by the number that's in front of the variable. And that's going to give us the missing value. And we can check our answer to make sure that it works. If we go back and plug in the number we get for that variable, if it gives us 2 equivalent ratios, we know that we've done that correctly. All right, so let's look at our examples. Okay, so we've got this proportion. We don't know what y is. Okay? So what we're going to do is find the cross products. So we're going to do 2 times y and 34 times 5. Well, 2 times y, it's just 2 times y. So I'm going to write this. After I do the cross product, I'm going to go over here and write 2 times y equals 34 times 5. I'm just going to write it. 2 times y equals 30, because we said the cross products of any proportion are the same. They're equal. 2 times y, I can't really do anything else with that, but I can write it. A lot of times we'll write it as 2y. Because remember, if there's nothing in between 2 and y, we assume it's multiplication. And then go ahead and multiply out 34 times 5. And we get 170. Yeah. So now we have 2y equals 170. So the last thing that we're going to do is we're going to divide by the number in front of the variable. So 2 is in front of the variable. So what we're going to do is divide both sides by 2. And what happens when you do that we've got 2 divided by 2, which is 1. And so you just got 1 y left over. In other words, you just have y. So by dividing by the number in front, we get 1 in front of the variable, and so it's just y equals 170 divided by 2. So that's the last thing we got to do is 170 divided by 2, which gets us 85. So y equals 85, and that's good enough. So the reason why we divide by that number in front of the variable, because we want to get just 1 y left over. And so by dividing by 2, 2 divided by 2 gives us 1 y right there. Okay, so let's look at our next example and do the same thing. So we're going to do n times 4 and 16 times 3. So n times 4, let's write that, and then 16 times 3. For right now, since we're just starting this process, I suggest write out like this first, and then we can multiply 16 times 3, which is 48. And what I would do, in multiplication, does order matter? Does it matter which number comes first? So just because it's a little easier to look at, I would put the number in front of the variable every time, because that doesn't matter. So put 4n instead of n times 4. That's just common in math, and it's a little easier to work with. So we've got 4n. We want to get 1n. So what we're going to do is divide that 4n by 4. Because 4 divided by 4 would leave us with just 1n. And then we've got to do 48 divided by 4 to get n equals 12. And just to check and make sure, if we plug 12 in for n, because we said n is equal to 12, when you simplify 12 over 16, what do you end up getting? 6 over 8, and simplify that, you get 3 over 4. So 12 over 16 simplifies to 3/4. That makes that true. We got that right. So you're going to cross multiply, get the cross product, set those equal to each other, and then you're going to divide by the number that's in front of the variable. Once you divide by that number, you got your answer. Okay, any questions? Okay, so you all go ahead and do the next 2 then. And it is okay on some of these. If you get a decimal as an answer, that's all right. Even though it's a fraction, if you get a decimal, leave your answer as a decimal. right, for our first one, find the cross product or cross multiply. It's another way that we say it. So we get x times 10 equals 4 times 9. And we can write that as 10x equals 36. So you're going to divide by 10 because we want to get just one x. So do 10 divided by 10 and 36 divided by 10. So x is going to end up being a decimal, and it's going to be 3.6. X equals 3.6. And getting a decimal for these answers is okay, because we want to be as exact as possible. So 3.6 would be x. We're going to do the same steps on the second one. We do 7 times 21 equals 3 times s. 7 times 21 equals 3 times s. 21 times 7 would be 147 equals 3s. Now, does it matter if the variable's on the right side, not the left? It doesn't, because it's still equal to each other. So I saw most everybody's still doing the same steps, which is correct. You're going to divide this by 3 because we want to get 1s. So you're still divided by 3, which means you're going to do 147 divided by 3. And you should get 49 equals s, or s equals 49. And so one thing to show you for this, we plug 49 in here. We know that you're going from 3 to 21. 3 times what gets you 21? 7. 3 times 7. 7 times 7 equals, so we got that correct. That's an equivalent ratio. Okay, any questions on this before we look at a couple other problems? All right, so these next few problems, we've got to do one extra thing. We have to set up the proportion before we solve it. So a couple of tricks that kind of help us with this. So after 2 hours, the air temperature had risen 7 degrees. We're going to write and solve a proportion to find the amount of time it will take at that rate for the temperature to rise an additional 13 degrees. So the first thing I want you to ask yourself, what two things, remember a proportion or a proportional relationship, there's always two things in that relationship. What two things are we looking at here? What two units or what two measurements? What two things are in this relationship?
Hours and temperature.
Hours and temperature. It does not matter which one you put on top and which one you put on bottom, as long as it stays on the top and it stays on the bottom. So let's put hours on top, and I'm going to write it like this first. Write it like this: hours over temperature. That way, when you set up the proportion, you know hours has to be on top and temperature has to be on the bottom. So this is not part of the proportion. This is just to help us understand how we're going to set it up. So a proportion is going to be two fractions with an equal sign in between. So one of the values for hours is 2. 2 over what? 2 over what? 7. So temperature goes on bottom. And what temperature goes with the 2 hours? 7 degrees. After 2 hours, it had risen 7 degrees. So 2 over 7. We've got one other number. Remember, we should have 3 numbers and 1 variable. Where does that 13 need to go? Top or the bottom? The bottom, because 13 is temperature. Temperature goes on the bottom. So on top, this is that missing piece. Let's put an X there. So that's our proportion. Now we just do the same steps that we already did. So we're going to do 2 times 13 equals 7 times X. 2 times 13 would give us 26 equals 7x. And then to finish, we've got to divide by 7, because that's the number in front of the x. So we're going to do 26 divided by 7, and that will give us a decimal. And we'll round to the nearest hundredth if we need to. about 3.71. Will be our answer. About 3.71. 3.71 hours. That's about how, so just about 3 3/4 hours, 3.7. But the big thing for these problems, because I've already seen we're getting the hang of how to solve a proportion, we've got to make sure we know how to set it up. Okay? So any questions about that, about setting it up? So figure out what two things we're looking at, hours and temperature, and then we're going to put one on top, one on the bottom. So let's look at our next one. So the ratio of 7th grade students to 8th grade students in the soccer league is 17 to 23. If there are 200 students in all, how many are in 7th grade? And this one's a little trickier. What two things are we looking at here? What two things are we looking at? Fiona, what's one of them?
The students.
What students? There's different types.
200.
200 students is what? 7th grade, 8th grade?
Both of them combined.
Both of them. Everybody see that? It's 200 students in all. So that's 7th and 8th grade. So we've got total students, we'll put that on top, over, what else are we comparing then? Total students to what? What's the question ask us to find? 7th grade. So total students over 7th grade. Alright, so now let's make our proportion. How many total students are in this first part? Well, 200 in the second one. What about the first piece of information? It's 17 to 23. So that means there's 17 7th graders and there's 23 8th graders. So how many total students are there? What? How'd you get 40? Yeah, add them together. So it's not going to be 23, because 23 is the 8th grade students. You've got to add 7th and 8th grade together. So it's going to be 40 total students. And of that 40, how many are 7th graders? 17 are 7th graders. So 40 over 17. And that's going to equal, now it's 200 total students over X, because we don't know how many 7th graders are out of that 200. So we would cross multiply. So we get 40x, or 40 times x, equals 200 times 17, which is going to be 3,400. And then we would divide by 40. 3,400 divided by 40. Times. We're going to get 85 as our answer. So the big thing with that one is to notice that we're trying to find the total students with 7th grade. It's not 7th grade and 8th grade, it's total in 7th grade. So we had to add that 17 and 23 there. Okay, any questions on that? One last thing, since I already showed you how to do the long, this does not always work, but sometimes it does work. How would you go from 40 to 200? Multiply by 5, right? If you did 17 times 5, what would you get? 85. So sometimes it works out that way. You just go from one to the next, but if you can't figure that out, cross multiplying always works for these. Okay? Go ahead and do the last one on your own. Set up the proportion first, give me the two different units that you're trying to find, like we did the last one, and then cross multiply and find that answer. just to make sure you've got your proportions set up right, which a lot of you do. It's total donors over type O or type O over total. You can switch it up if you want. Make sure you add those two together. Okay, so once we set up our proportion, and if you did 37 over 80 equals x over 300, it's the same thing. As long as total donors 80 and 300 are on the same side, and 37 and x are the same. You get 80x equals 11,100 when you cross multiply. And then we've got to divide by that 80 that's in front of the x. And so what type of number do you end up getting after you start dividing? It'd be a decimal, right? I think it's x equals 138.75. Donors are what?
Type O donor.
Well, a donor is what? It's a person, right? Okay. Can you have 138.75 people? So what should we do with this 138.75? Round it up. Yes. Anytime you're talking about people or animals, if you have a decimal, you always round up because you've got to account for that extra person. So x equals 138.75, but our answer should be 139 donors. So don't say that x is 139 because x is not 139. X is still 138.75. But you do need to make that your final answer should be 139. Question?
Shouldn't these type O donors not donors?
Yeah, 139 should be type O. Yes. Any other questions? All right, so there are a few problems to be working on.